Well, hello, everybody. I'm not sure when you're going to be watching this. I'm sure some of you are going to check it out on Monday because that's your routine, but it's also possible that some of you are going to find this posted earlier than that. I'm recording this actually on Friday, and I plan on posting it right away so that those of you who want to start preparing for the quiz will have as much time as possible to do that. So the review assignment is well, as you're watching this video, it's posted already, certainly. Um, and some of your friends may have started on it already. Some of your friends may have finished it already. But I just want to make sure that you guys know what's going to be on the test because so far over the last 5 days or so, we've just been focused on what a sine or cosine curve looks like. And certainly that is the emphasis. The number one most important piece of what we've been doing is the sine and cosine curves. In fact, I'd say that's pretty much what this chapter was about. But on the quiz, we're going to go back to basics a little bit more and look at some stuff that came before that. So keep this in mind. I realize that I will not be standing behind you watching and monitoring, but if you are using your calculator, you are not doing these problems as intended. You certainly should not need one, but again, I can't say that you can't use it, period, because that is impossible for me to enforce. But you should not be using your calculators almost at all. If you have a simple four-function calculator, that's okay. Adding, subtracting, multiplying, dividing is all right. But if you've got a calculator that will give you the values of sines and cosines, then you are missing the point of this chapter. When I say, above all else, know the sine and cosine curves, it's got to be automatic at this point that we know a sine curve has this kind of a shape. That's one full period of the sine curve. I will use the phrase it starts at 0. Technically, there is no start or finish because it goes on indefinitely in both directions. But as I'm thinking about graphing it, the normal value for the sine function at x or theta equals 0 is 0. And then by the time I get done with one full period of the graph, we're back to 0. And if I divide it up into 4 sections, we've got this 0, 1, 0, negative 1, 0 pattern to the graph. Just that's what a sine curve looks like. And equivalently, a cosine graph starts at the top and goes 1, 0, negative 1, 0, positive 1, and then yes, it keeps going forever in both directions. But that one period of the graph is what we're looking for. The period of the graph is 2 pi if you're in radians, or it's 360 degrees if you're doing it in degrees. And so each of these intervals is either 90 degrees or pi over 2 radians as we're making our way across the curve. And so the intention of questions like the ones that I've got on my screen right now is not to plug it in your calculator. I can teach a second grader to do that. What I'm looking for from you guys is to say, well, I know what a sine curve looks like between 0 and 360. And by the time I get to 360, one full period of the curve, we're back to the x-axis. So that's 0. For something like cosine of negative 810, well, that goes beyond 0 to 360, but I can think about going backwards. 360, then 720. And so if I'm at negative 720, whoops, 720 degrees, and then we're going to go back 90 degrees more than that. And so if I'm thinking about what a cosine curve looks like between, I'm not even sure what it is, back here, let's see, negative 720 minus 360 would be negative 1080, but that doesn't really matter to me. Here's the important place that we're looking. We're 90 degrees less than negative 720 degrees, and my graph is again crossing the x-axis there, so my answer is 0. Sine of 3,690 degrees, well, I don't need a calculator to know that 3,600 is a multiple of 360. So same idea, if I'm looking at one period of this graph, it's a sine curve, so it starts in the middle. And if this is 3,600, then 3,690 is the next spot over, and looks like we are up at the top for that one. So the answer is 1. And then finally cosine of negative 1080. I guess I figured that already. That was back here, and the cosine value of that was 1. So that's what I mean by um, using the sine and cosine graphs to figure out values of these. And then similarly, if I say give all the values of theta for which cosine of theta equals 0, I am not going to be mad at all if you go back to the unit circle and you're thinking in terms of the unit circle, because that's also an important skill in this class. But the intention for us in this chapter is to say between 0, let's go between 0 and 2 pi for this one. Let's switch over into radian mode. If I'm looking at the places where the cosine graph is equal to 0, between 0 and 2 pi, well, here's pi halfway in between, and so halfway between the origin and pi is pi over 2, and halfway between pi and 2 pi is 3 pi over 2. And so those are the two places where it's equal to 0. Those are my answers for a question like that. Or if I have a sine question, sine of theta equals negative 1, same idea. Between 0 and 360, if I'm looking for all the places where sine is equal to negative 1, the only place happens down there, and that is halfway between pi and 2 pi. So we're looking at an answer of 3 pi over 2, or 270 degrees if you're doing the problem in degree mode. So those are some of the old things. I'm not spending a whole lot of time on them because frankly, they should be stuff that we're pretty good at this point. I just want to make sure that you're aware that there will be questions like that on the test, both radians and degrees. Make sure you can do both versions. And then finally, the bulk of the test, or large quiz, small test, whatever you want to think of it, is to take an equation and say what is the amplitude, period, phase shift, and vertical shift, and then of course come up with what the graph is going to look like. So I'll just do a couple of these quickly. If you want to see more examples of these, we've got a backlog of videos at this point, each one going through a different step in the process. And there's different ways of doing these, but the way that I go about this is first finding these 4 properties. Amplitude is the absolute value of that number, the coefficient in front. Please, please, please do not tell me that that is negative 5. The amplitude is positive 5. The period is either 2 pi or 360 degrees divided by the number that's multiplied by the x here. I don't have anything in front of that one, so it's just 2 pi. I'm actually going to peek ahead. I forget. I think the next problem, I wanted to do that in radians. Shoot, I'm going to have to fix that. But let's stick with degrees for this one. The period is going to be 360 degrees for this one, or 2 pi radians. Either one would be okay. It's not obvious from this one whether it's degrees or radians. I would have to state that in the context of the problem. Phase shift, here again, if I've got x plus something, x minus something inside the parentheses, that would be a phase shift, but there's nothing happening here. And then my vertical shift, if you want to just say 6, if you want to say plus 6, or if you want to say up 6, any one of those is going to be okay. And then when we graph something like this, we will first make our axes. In fact, the way that we've been graphing these things, really the biggest thing that we have to worry about is how to make the scale on our axes. And the way that I've been doing it is counting off a certain number of them, at least 4 of them, given the size of my increments here. I don't have quite enough to make them 4 wide, so I make them 3 wide. And because the period was 2 pi, I'll say that, nope, I'm sorry, I said the period was 360, so we'll stick with that, which means half of that is 180. Sorry about my writing. Half of that is 90. And then halfway between 180 and 360 is 270. And since we're counting off by 90s, the next one on my scale would be 450 degrees. Not completely necessary to do that one, but why not, right? And then our midline has moved up by 6, so the middle of the graph lies at 6, y equals 6 instead of y equals 0. And then my amplitude says we'll go up 5 from that and down 5 from that to get those values. Shoot, I did this in radians. That's okay, I'll keep it with this one. And then figuring out what the graph looks like. There is no phase shift, so we're just starting right at x equals 0. It's a negative sine curve, so it will start at the origin, but it will be decreasing. And so down to -1, up to 0, up to +1, down to 0, down to -1. And then before I play connect the dots, I like to put those points at the 1/3 marks to give myself a graph that is somewhat smooth and beautiful. I've said it before and I'll say it some more. I'm not looking for perfection here, but I'm looking for a non-zigzag curve. I'm looking to see at least one full period of the graph. And then I will up the degree of difficulty a little bit. And I changed this one. I was going to do this in degrees, but I want to switch it around and do it in radians. So I'm just going to copy and paste a little bit here. This is the problem that I want to take a look at. Amplitude is the absolute value of the number that is in front, the coefficient. Of course, it is not a negative value. Period is, oops, I got an X missing. Sorry, guys, I'm doing a terrible job today. Oh, I do have an X there. I'm not doing as bad a job as I thought. I'm going to think of this as 1/3 of X. And so my period is going to be 2 pi divided by that 1/3. This is x over 3. That's the same thing as 1/3 x, and my period is 2 pi divided by that k value that's multiplied by the x. And then 2 pi divided by 1/3 is the same as 2 pi times 3, which is 6 pi. To see my phase shift, please, please, please don't be that student who writes down pi over 4. We need to get this in factored form in order to see what the phase shift is. So I'm going to factor out the 1/3 from the stuff that I've got inside these parentheses. It's still -3 times cosine of some stuff plus 6. But then this part of it in factored form, if I take out the 1/3, the question is either 1/3 times what gives us x over 4, or what is x over 4 divided by 1/3. Either way, we're going to end up with an answer of 3 pi over 4. If you're not sure if you're doing this right, if you're not sure, do I multiply by a third? Do I divide by a third? What makes sense? Always think you should be able to redistribute this and end up back where you started. 1/3 times x, there we go. 1/3 times 3x over 4. The 3's cancel out and we're left with pi over 4. So there's our factored form, and now I see my phase shift. Just like with the vertical shift, if I just say 3 pi over 4, it is understood that you are talking about a phase shift of positive 3 pi over 4, which it is. This is x minus the phase shift. If you want to say plus 3 pi over 4, that's okay. If you want to say to the right by 3 pi over 4, that's okay also. But negative 3 pi over 4 will not get the point. You're moving in the opposite direction if you say this, that the phase shift is negative. And then finally, vertical shift of 6 or plus 6 or up 6. Any one of those is going to be okay. All right, and then I'm going to have to copy this and paste it again onto the next one because I goofed up. Sorry about that. So here is the graph that we are trying to do. As always, figuring out what our horizontal and vertical scales look like. And by the way, I have been made aware that at least one of the other teachers is doing this in a slightly different way that I am doing. I don't want to throw a whole new different method at you, but if you've been working with a friend who has a different teacher and you've got a way that works for you and makes sense and of course is correct, then by all means go ahead and do that. But the way that I'm going to think about this is I have a period of 6 pi. It's a pretty big chunk. My phase shift is to the right by 3 pi over 4, which means I am going to put my vertical axis way over here on the left side. I will do my usual counting off by, well, I guess I don't know yet. I haven't figured that out. But when I get to the fourth one, that is going to represent my period of 6 pi. Half of that is 3 pi, and half of that is 3 pi over 2. So I am counting off by 3 pi over 2, 3 pi over 2, 6 pi over 2, 3 pi, 9 pi over 2. Let's see, this would be 12 pi over 2, but that's just 6 pi. And then finally 15 pi over 2. And then for our vertical scale, I've got my +6 tells me how far the midline has moved up or down. In this case, moved up by 6. My amplitude says I'm going up 3 from that and down 3 from that as well to give myself a scale that looks like that. I have again goofed up. Let's make that 15 pi over 2. Everything else I think is okay here. And then I am ready to graph. So I know that it's going to make it through one full cycle by the time I get to 6 pi, but I also have my phase shift by 3 pi over 4. So how far is a 3 pi over 4? Well, if one of these intervals is 3 pi over 2, half of that is 3 pi over 4. So when I make my graph, my negative cosine graph, which is going to start off down at the bottom, that point that would have been at the y-axis has been moved over by 3 pi over 4, which is half of 3 pi over 2. There is my starting point. I'm even going to mark on here that this is 3 pi over 4. I would suggest you do that as well on the test. Let's see, the negative cosine curve would then go through 0, but that point has also been moved over by 3 pi over 4. Then it would be up at the top, but that point has been moved over by 3 pi over 4, and then down at the bottom, in the middle, then down at the bottom, and then back up to the middle. I, as always, am going to put those points that are closer to where it crosses the midline as a guide for me to draw a fairly smooth curve. And here we go. Not perfect, but not too bad either. I'll switch over to the one that I did a little bit more carefully. And there we go. I'm publishing this probably on Friday afternoon, so it will have been up there. I don't plan on publishing anything new on Monday. In fact, I'm guessing that a lot of you will probably see this for the first time on Monday, but be ready. The quiz will be on Tuesday, no matter when you're watching this for the first time. If there are any other questions from the review assignment or anything else from this chapter at all, certainly let me know. Certainly get back to me. Otherwise, good luck to you on the quiz. And I will see you when we start the very last chapter on Thursday. All right, good luck. See you later, everybody. Bye-bye.